All right, Harmony Science Academy Algebra 2. We're looking at exponential functions. Okay, they've got their own thing. The main thing is you want to have some solid notes that you can trust. Okay, so you don't stress more than you have to. Anyways, so in your notes you have this image. Okay, and basically the whole purpose, at least here, is to know what an exponential function looks like, right? It's got kind of this curve where something just all of a sudden grows exponentially, or something can just decay exponentially. Okay. The other thing is, because we are talking attributes, the fact that there's an asymptote. Okay. In this case here on the bottom, that's going to be important. So for example, this would be the line y equals 0, where you find the asymptote. Okay. Why? Because you don't go up, right? There's kind of this invisible line here. Whoops. Okay. So that right there, again, it's an invisible line. Yes, it's on the x-axis, but it's an invisible line that these graphs don't touch. That's the asymptote. Okay. And the reason I'm spending time here is, again, it's not up here 1, 2, 3. It's not -1, -2. It's at 0. Okay. Y equals 0 because it did not go up or down. Okay. Something important as we move along. All right. Anyways, you're going to have this to look at. Okay. There's going to be two parts to this. This first part, it's just attributes, right? You guys know attributes, and you're going to apply it to these kinds of graphs. They're very intense, but they'll go in the calculator. You'll get the graph, and then you can tell us about all these specific attributes. Okay. So we'll do the second one. Okay, we're going to go and do this one. And like always, it's a good idea to have the parent function. Okay. So there's more specifics, but we gotta come in at this pretty simple first. So here's the parent, 2 raised to the x, and here's the function. Okay, here's that part, the 2 raised to the x here with all these other stuff. Okay, we're not gonna deal with the transformations. All we care about is this graph. Okay, so we've seen this guy before, so let's go ahead and take advantage. Okay, all we're going to do is fill it in according to what we see, and our graph is the one that's in red. Okay, so anyways, domain looks like it goes left and to the right forever. Okay, so we're going to say, let me go blue, or maybe green's better. Negative infinity to infinity. Okay, now again, I cannot include these these are not numbers, so it should be parentheses. Okay, negative infinity to infinity. Here I can pick whichever I want. The set of x's such that we go all the way left and all the way right. Okay. Now the range. Okay. Again, we're looking at red. Okay. 1, 2. Okay. By the way, this line here looks like it's going to have an asymptote. Okay. I'm going to jump the gun. I don't know if you guys will allow me to do that. Okay. But it looks like this red line's got an asymptote about here. Oops. Okay. All right. So anyways, that means that I don't go below 2, and it seems to go on forever to infinity. Okay. Put a parenthesis there. From 2, it does equal. Well, actually it does not equal. Okay. So 2 doesn't equal, and it goes up to infinity. All right. Well, here we got set builder notation. My set of y's such that my y's are bigger than 2 but less than infinity. Okay. And up here, since I'm not including 2, okay, y cannot be 2 because that's the asymptote. Okay, in this case. All right, little details. All right, the x-intercept in this case, again with the red exponential function, it's 1, 2, 3. Okay, and do I have a y-intercept? I do not. So I'm going to say NA. Okay. All right. Axis of symmetry, is this symmetric? No. Okay, asymptote. We discussed that. It looks like it's this line y equals 2. Okay, it's an invisible line that the graph gets close to but doesn't touch. Do we have a maximum? Okay, we don't have a maximum point. So in this case, we're going to say same thing, NA. All right, and is there a minimum? Okay. Now, although this line never touches 2, it keeps getting lower, 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 so there is technically not a minimum either. Okay. Now, you have to be on the lookout. Okay, pay attention. You know, sometimes they might just restrict the domain. We've seen that they might tell you, hey, only look at -4. So 1, 2, 3, 4. 1, 2, 3. And they might tell you, hey, only look in this area here. Okay, we've been here before. So if they were to say that, okay, let's say the domain such that x is less than 3 but bigger than or equal to -4. Okay, it happens, right? We've been in those cases. Then you could say that this right here would be the minimum. Okay, and this one over here would be your maximum if they restricted the domain. Okay, giving you guys something to think about. All right, let's go ahead and move on to the next set of notes you guys have. Now, this is basically a formula. Okay, it's a pretty simple formula. Okay, you've got the amount after t time periods, the initial amount, number of time periods, and the rate. Okay, it's positive if there's growth, negative if it's decay. All right, so you're going to be looking at problems like this. Okay, so this is coming up on the CBA, but this is not intimidating at all. Okay, so once you get here, you're going to know that, hey, I've got to use this formula. Okay, discrete. We'll talk about this, what that word means a little more later. Okay, discrete exponential growth or decay functions. So we're going to be in this situation where all we need to do is plug in. Okay, very simple exercise, so take advantage and practice. Okay, rentals in high-rise apartments buildings get more expensive higher up. Since the views get better, the ground floor, which is floor 0, rent is $1,520. The rent increases. Okay, so you're looking for words like this that are gonna guide you to decide, am I gonna have growth or decay? So they're not gonna tell you always growing or decaying. You're gonna look for words. Okay, here's the tip: look for the word that will tell you if you are adding or subtracting the rate. Okay, so increasing 2%. What is the rent on the 7th floor? So we need a couple of things. Okay. We don't know the amount, but they should give us the rate, the initial amount, and the number of time periods. So it looks like this is the initial amount, 1520. Then what is it that I need? I need 1 plus R. Okay. 1. We have an increase, so it is going to be a plus. R, the rate is 2%. I have to turn it into a decimal, which is, okay, be careful. It's not 0.2, it's 0.02. What is the rent on the 7th floor? Okay. So now the only thing that I'm going to encourage you guys to do is go one step, because you want to match it on your answer choices in the CBA. So this is what you're looking at. Okay. Now, this seems simple. It is simple, but something to pay attention to is when it's increasing or when you have growth, notice that this number is going to be bigger than 1 for sure, because you're adding a rate. Okay. So that's going to be important. So let me put it in here. Growth. Okay. That's how you know you're probably on the right track, because it's bigger than 1. Now let's go ahead and go to this one. Okay. For tax purposes, a car rental company assumes each car in their fleet depreciates. Okay. By 6% per year. If the initial value of the car is $25,900, what will it be when the car is? Okay. So again, pretty easy, but you've got to be looking for those very important guiding words. We have the initial amount. Yowza. Okay. We need the same setup. 1. Now this is depreciate, so it's got to be minus the rate. Okay. Pay attention to that part, which is 0.06. And when the car is 7 years old. Okay. Now look at what's going to happen here. I'm going to have the initial amount. I'm going to subtract this. Okay. So this is 1.00, which is going to give me 0.94 to the 7th. Okay. And here I want to pay attention to the fact that this is less than 1, so this is decay. Okay. Now after this, if they're actually looking for the amount, you can go ahead and run that in the calculator, no problem. But knowing growth and decay from visually setting it up and looking at these exponential functions is going to be very important. All right. Appreciate your time. Catch you in class, guys. All right. And sorry, right before I let you guys go, I think it's going to be very important for your notes to link, like that word with adding, and in this case, this word with subtraction. Okay, again, a lot's coming, so you want to have really good notes. Again, thank you. See you in class.